So question 6, again, we're doing basic operations with square root radicals. So they want us to simplify this expression 6 times the square root of 40 minus 3 times the square root of 90. So as we mentioned, square root is the inverse operation to square a number. So as we pointed out, if you have a perfect square, it's pretty easy to do the square root. So to do a perfect square, you just pick a number, say 9. If I square it, 9 squared is 81. So 81 is called a perfect square. So if I want to take the square root of 81, notice how the square root of 81, what squared gave me 81 was 9. So that just takes me back to the beginning. That's what square root does. It undoes squaring. So this is a unique symbol we have in math. Now, if a number is not a perfect square when taking the square root, then the answer is represented as an irrational number. It can be left in what we call simple radical form. A calculator can be used if I want to turn it to a decimal. And then, of course, we'd have to round the answer as well. So what they want us to do here is they want us to simplify a square root. To do this, one of the strategies is we want to do a prime factorization. We want to identify the perfect squares. I want to pair up those common factors, and I bring those outside the radical. The non-perfect squares are multiplied back together and left inside. So in our problem, we have 6 to the square root of 40 minus 3 square root of 90. One way of doing this problem is doing a prime factorization of what's inside the radical. So the 40 and the 90. So remember 2, 3, 5, 7, 11, and sometimes 13 are your prime numbers. So if I'm talking about 40, well, since 40 is even, 2 goes into 40, and 40 divided by 2 would be 20. And then I'm turning myself to the 20. 20 is not prime, but 2 does go into 20. 2 goes into 20 10 times. 10 is not prime, but 2 does go into 10. 2 goes into 10 5 times. But notice that 5 is prime, so 5 goes into 5 one time. So notice that 2 times 2 times 2 times 5 represents 40, and this is what's called a prime factorization. So this gets changed into 6 times 2 times 2 times 2 times 5, minus then 3 times the square root of, and let's look at this 90. And again, you can use a calculator for this as well, but 2 does go into 90 because half of 90 is 45. From there, 2 does not go into 45 because 45 is an odd number. Only even numbers are divisible by 2. But 3 does go into 45. I think we just did that a minute ago. 3 goes into 45 15 times. And then 3 does go into 15 5 times. And then 5 is prime, so 5 does go into 5 one time. So 2 times 3 times 3 times 5 does represent 90. So what I'm going to do is rewrite 90 as a prime factorization. 2 times 3 times 3 times 5. Now to simplify the radical, what we do is we pair up to make perfect squares. So for every 2 2's, that means we bring out 1 2. So that means the 6 stays out there, and that pair of 2's brings out 1 2. So that comes out, and we're left with this 2 times 5 on the inside. Over here, the 3 is already out there, but notice how there is a pair of 3's. So for every pair of 3's, that makes a perfect square. So that comes out as a 3. And that's going to leave me then a 2 times 5. So if we clean this up, we put the outside numbers together. 6 times 2 is 12. We put the inside numbers back together. That's going to be a 10. Outside numbers, 3 times 3 is 9. Inside numbers, 2 times 5 is 10. So notice how these are like radicals. Since they're like radicals, this means there's 12 square root of 10's, and we're going to lose 9 of those. So if I lose 9 of them, this leaves me 3 square root of 10's. And that's what we mean by simplifying. And that would be our answer to this problem that's now simplified. So they do not want us to change this to decimal. They want to leave the answer in radical form, simplified. So that would be our strategy to work this problem out.